Hey guys, it's Coach Russell. I am recording the video for our lesson for Wednesday, August 12th, and this is going to be over the rational numbers, which is a part of the real number system. So you guys get this at the beginning of the year in 6th grade, you get it at the beginning of the year in 7th grade, and you will also get it at the beginning of the year in 8th grade. So the way this is represented is these are called, normally they're circles, but they're called concentric because they are inside of each other, kind of like nesting dolls, little dolls that are inside bigger dolls, right? So these are concentric circles, and the reason why they are inside each other is because all of these things right here, these subcategories, all are a part of this, okay? All of the, like, natural numbers are whole numbers, and whole numbers are integers, and it just keeps flowing like that. So when we actually go to use this, we're going to start with rational numbers, and we're going to just run down into the smaller subcategories. And what we're looking at here is our number line. So when you include a number line and you have your number line on there, you have 0, and then you have your positives on this side, you have your negatives on this side. So we're just going to start with a very large specific number line, and then we're just going to cut pieces of it off as we go. It's kind of like being in a club, and you're in a club, and then you're in a specific group inside of the club, and then you're even a more specific group. So it just keeps getting smaller and smaller and smaller. So let's start with some definitions to refresh your memory. So this is what you should have, and we're going to go down, if it'll let me. Here we go. And so this is our note-taking sheet that we're going to just get some definitions, practice with some numbers, and then we will go in and practice with some statements. Okay, so the very first thing that we have here is the definition of rational numbers. And the way that I like to define this, so those of you can just type it in your notes. So you have rational numbers, and this is going to be all numbers, including decimals, fractions, and whole numbers. Okay, so that's going to be all the numbers that you need in 7th grade. Now, when you get to 8th grade, you're going to add in irrational numbers, and it's going to be like that. Okay, so that's everything. That's all fractions that you have. That's going to be every decimal that you get in 7th grade, and any number, period. So if you see a number that you have, it'll be a rational number. And then we're going to break it down into smaller categories. I'm going to change the font to a smaller size real quick. Okay, I think that's good. All right, so when we talk about it includes all decimals, the decimals that we're looking at for rational numbers are terminating and repeating. If it's a decimal that continues to go and it doesn't end and it doesn't repeat, those are irrational numbers, and that is 8th grade. We do not work with irrational numbers really in 7th. So you will have just terminating and repeating decimals. So definition for you guys for terminating decimals and an example is going to be a decimal that ends. And an example of that is going to be 1.75. If you're going to represent like $1.75, that's it. It's a terminating decimal. A repeating decimal, of course, is exactly what it sounds like. It is a decimal that repeats. So you guys learn that 1 1/3, that 1/3 is 0.3 repeating. So you would just do and normally you would put a repeating bar over it. I don't have that function. So we're just going to leave it like that. So it is a repeating decimal. So that includes every number, every small little tick mark like what's on a ruler. And as far as the number line goes. Now we're going to get even more specific with our groups, and we're going to do definition of an integer. So an integer is going to be positive and negative whole numbers. So on a number line, you're going to see -3, -2, -1, 0, 1, 2, 3. So that would be how you would see it on a number line. All of those are integers. No decimals, no fractions, okay? So then you have whole numbers. So we're going to even take and make our number line even smaller, and we're going to do positive numbers that start at 0. So in our example for that is we're just going to get rid of all of the negatives. So we're going to rewrite our number line starting at 0. So 0, 1, 2, 3, and it keeps going to forever. Now, that is all the information you guys get in 6th grade. So in 7th, we're adding in natural numbers. So the way that I like to remember natural numbers, if you are given a bowl of apples, when you naturally start counting them, what number do you naturally start counting at? So most people don't start with, oh, I have 0 apples and now I have 1. You just start with the 1. So the definition for natural numbers is going to be positive numbers that start at 1. So again, it's just like your number line, but we're not including 0. So the only difference between whole and natural is the 0, okay? So we're just going to do 1, 2, 3, and then it just keeps going on from there and there and there. So what I would like to do now is, so we have this practice. So when we go to see what these numbers are classified as, they're all going to start at rational. But then we have to go down and look to see if it qualifies and read the definition of an integer and see if it qualifies to do that. So this is going to be like our step 1. And then if we say yes, it's a rational number, we're then going to go down and look at integer. If we say, oh, it fits the definition in the examples of integers, we will go down to whole. Then if we say yes on that, we're going to go down to natural numbers, okay? So we're just going to keep going down and down and down until, we say no or that we end at natural. So if I look at number 1, which is 0.875. So we know by definition that all the numbers we're using, including decimals, is a rational number. So I need to put on that this is rational. I'm just going to put a capital R that I know that it's a rational number. So I said yes to rational numbers. Then I'm going to go down to integer. Integers are positive and a negative whole number. Well, is 0.875 a whole number? No, it's a decimal. So no, it is not an integer. So I am finished. I do not go down to whole or natural. It can't, if it is not an integer, it cannot be whole and it cannot be a natural. So once I say no, I'm finished. So for example, look at number 2. Number 2, 0. Go to the definition of rational numbers. All numbers, including decimals, fractions, and whole numbers. Well, 0 is a number, so it is rational. So I'm going to put my R. Now that I said yes to rational, I need to go down and look at the word integer. Integer, positive and negative whole numbers. Well, is 0 a whole number? Is it on that number line on the example that I gave you? Yes, it is. So it is an integer, and I'm just going to put an I. Then since I said yes to integer, I'm going to go down to whole number. Whole number, positive numbers that start at 0. Well, that is 0, so it qualifies as a whole number. And since I said yes to whole, I'm going down to natural. Natural numbers, positive numbers that start at 1. Well, 0 is before 1, so it can't start there. So is it a natural number? And the answer to that is no. So let's look at number 3, 17. Well, we already discussed how every number is a rational number, so 17 is rational. So we'll go down to integer. Is it a positive and a negative whole number? Yes, it is. 17 is a positive whole number. So it's on the number line on the positive side, okay? So it is an integer. So now I want to know, I said yes to integer, so I go down to whole. Is it a positive number that starts at 0? Well, yes. If I started at 0 and counted up, would I come to the number 17? Yes. Yes, I would. So it is whole. All right. I said yes to whole. Let's look at natural. A positive number that starts at 1. If I started counting at 1, would I hit 17 if I continue to count? Yes. So this number is also natural. So it is all of them. Okay. Number 4 is a little trick. 15 over 3. What is, so it's a fraction, right? So it's a rational number. But is it an integer? Now, it says a positive or negative whole number. Well, 15 over 3, what we really use a lot in 7th grade is going to be fractions. Not as much as what you did in 6. We use fractions as division. So 15 over 3 is the same thing as saying 15 divided by 3. So what is 15 divided by 3? Well, the answer to that is 5. So I'm going to go ahead and 15 divided by 3 equals 5. So I'm no longer looking at 15 over 3. I'm now looking for classifying the number 5. So we did this. Okay, I'm going to mark this out. And now it's 5. So is 5 a rational number? Well, yes, every number is a rational number. Is it an integer? Is it a positive number, positive or negative whole number? Well, it's on the number line on the positive side, so yes, it's an integer. Is it a whole number? Is it a positive that if I start at 0 and go up, will I come to the number 5? Yes, it's a whole number. Natural number. Is it a positive number that starts from 1? So if I started at 1 and counted up, would I get to 5? Yes. And that's all that we have. Okay, natural numbers, negative 2/5. Is it a rational number? Well, all numbers, including decimals and fractions. Can I divide 2 divided by 5 and get a whole number? No, 2, my numerator is smaller than my denominator, and it won't go in evenly, so I will get a decimal. So, negative 2/5, that's going to be a rational number. So let's go down to integer. Is it a positive or a negative whole number? No, it isn't. It's a fraction. So we can just leave it as rational. Number 6, negative 29. Is it a rational number? Well, it qualifies as all numbers, so yes, it's rational. Is it an integer? Is it a positive or a negative whole number? Well, it's a negative number, and it's a whole number, so yes, it's an integer. Is it a whole number? Is it a positive number that starts at 0? Well, it's not positive. It's a negative number. So whole numbers can only be positive. So that's it. It's done. So number 7. 9. Rational numbers? Yes. Take a few seconds and see if you can categorize this number by yourself. I'll go ahead and give you a minute to do so, or a couple of seconds. Read through the definitions. If you say yes, go to the next one, and then I will check it. Okay, so 9, it's rational. It is a positive whole number, so it is an integer. And it is a positive whole number starting at 0, so it is a whole number. And it is a positive number starting at 1, so it is a natural. So it is all of them. Okay, do number 8. Okay, so 8 is a repeating decimal, so it is rational. And so we go down to integer, but integers have to be whole numbers, and this is a decimal, so that's it, we're done. Okay, so number 9. So number 9 is negative 1.62. All right, so negative 1.62, that's going to be a terminating decimal. It's a negative terminating decimal, but it's still a terminating decimal, so it is rational. And if you look at integer, of course, integers have to be whole numbers. They cannot be decimals or fractions, no matter if they're negative or not. And it's a decimal, so it is not an integer, so we're done. Number 10, 8 3/4. So that has a fraction in it and a whole number. So that was going to be rational, of course. But can it be an integer? And even though it has a whole number attached to it, it still has a fraction. So if you were to convert the 3/4 into a decimal, it would be 8.75. So we would still be just like number 9 and just like number 1. So it would still be a decimal, which will only make it rational. Okay? Now, you also have these in statements. Maybe. Okay. Wasn't cooperating a while ago. Okay, so I'm going to erase this real quick. Okay, and then I'm going to pull up the other sheet. And then we'll talk about how these statements look. Okay, so this is it. It's just 2 on one page. It's still the same thing. So whatever's on the left is the same thing on the right. So you have number system analysis. So you're going to do the same. So they're giving you a statement, and you need to be able to see if it's true or false, and why would it be false. So we're going to talk about that. So number 1 says all integers are rational numbers. Well, the definition that we just wrote down says all numbers are rational numbers. So are integers included in all numbers? And the answer to that is true. So we're just going to write true. Okay. Number 2, all integers are whole numbers. So if I had an integer of the number 5, is that also a whole number? Yes, because the definition of a whole number starts at 0 and counts up. But if I had an integer of -3, is that a whole number? Well, no. So, are all integers whole numbers? And the answer to that is false, because of negative numbers, right? So number 3, no positive numbers are integers. So the definition of an integer is positive and negative numbers. So that's false. Okay. Number 4, some rational numbers are integers. Okay, so when we look at rational numbers, are some of them in the integer category? Did we classify any of the numbers on that second page on the practice side? Did we classify any of those as integers? And we did. So this statement is true. We didn't classify them all as integers, but we did classify some. Okay, number 5, some integers are whole numbers. So did we classify any of those numbers as whole numbers or as integers than as whole numbers? And we did. So if you looked at number 2, number 4, 3, and 7, some of those integers were whole numbers. Now, did we classify all of them? No, but we did classify some. So that's true. All rational numbers are whole numbers. So every number that we classified as rational, did we also classify them as whole? And no, we did not, because we have number 5, number 6, number 8, 9, and 10 that were classified rational, but were not classified as whole. So this is false. All whole numbers are integers. So when we classified whole numbers, did we also classify them as an integer? And the answer to that is yes. So every time we put a W down, we also put an I down. So this is true. So number 8, some whole numbers are negative. So are any of the numbers that we classified as whole that have the W by them, so 2, number 3, number 4, number 7, were any of those negative numbers? The answer to that is false. The definition itself says a positive number from 0. So no whole number are negative. So this is false. Okay, so that's our notes. You can use this sheet and the first sheet to help you with the assignment. It's a Google form, and that's going to be along with this. So you'll have the Google form that helps you with this. Use your notes, and you guys have a great day. Thank you very much.